Hello everybody, so I suggest that we start. It's 4:30. So I'm Franck Le Gall from AGM, and I'm glad to open that session here in Malaga on digitalizing the water sector. And I will start by providing kind of overview of some activities we have in relation to linking the physical and digital world with open source and standards for water resources. A few words about myself and the company. So I'm from EGM. We are a SME based in south of France, quite involved in research. A lot of activities is about research, where we are involved in many different European projects. And in relation with the water domain, I'm involved in the ICT for water cluster, and I will explain a bit more about it later on, where I'm chairing the Smart Water Working Group, and I'm also vice chair in the IGC standardization group, which is working on defining the NGSI LD specification. In EGM, the company, what we do mostly is that we are working on the whole IoT value chain. So from the bottom, sensors, integration, electronic boards, embedded software. Then all the software layer, where we developed the Stelio, which is an open source context broker for the FIWARE environment. And we are deploying it in a number of different use cases for customers. And the ultimate aim is at the end to provide a system able to help in decision support. So there we are providing KPIs and so on for DSS. As I was saying, we are quite involved in the European research, so a bit of context there. So the European Commission has recognized the facts about the water. So that's first, it's about the value of the water resource, and it's become scarcer and scarcer, so we have to take care about it. But at the same time, the European Commission also recognized the value of the data. And mixing the both of them, they have been calling for a research project looking at ICT for water. And here's a picture of the water life cycle, quite complete one that they produce, and they are really covering the whole chain, because we cannot neglect any one of these aspects. So each time we're thinking about water, then we have to think about the whole value chain. So ICT for water clusters that I'm mentioning has been funded in 2012. We were starting to fund such a project. And at that time, it was only 5 projects. But year after year, this cluster of research project has been growing. And now it's more than 40 projects, 400 organizations, which are part of that cluster. And these clusters allow us to bring or to create interactions with other initiatives at the European or international level. One of the key items which has been produced by the cluster is an action plan for water service. It's freely available on the web, and it defines the path for this project. So it gives year after year where we are heading the European research for the water. And the way the work is organized is a number of different working groups, which are looking at standardization and interoperability. Later on, we'll hear about Aitor, who is chairing that group, about data sharing, smart water, cybersecurity, actor awareness, policies, and business models. And these groups are meeting every 2 or 3 months to progress along the action plan. One interesting action which came out of that cluster is that some months, a number of projects, being FIWARE for water, Aqua 3S, Lotus, Score Water, Digital Water City, and NAIADES, together meet in a workshop and agree that there are some common interests in working together and defining data models for the water domain. And all these projects were bringing domain-specific use cases, needs over the whole water life cycle. And they wanted to put that together, and with the help of external experts, we were bringing more generic models for IoT, for example, or geographical information systems, social networks, and so on, build really water-focused data model. And there the FIWARE Foundation is quite pushing this. And later on in the presentation, Alberto will go into this part. An example of what is being produced by such project. Here it's in the case of the Aquas 3S project. Aquas 3S is focused on security and safety in relation with the water and about standardization on this topic. So it has developed, or it is developing a number of use cases, again looking at the different parts of the water life cycle, and quite wide usage of different data. So it's our data sets. It's about drones acquired data. It's about satellite data. It's about sensor-based data. Also from social networks, call centers, and so on. Because obviously, when you are thinking about security, safety, about the water, then we have to think about risk, urgencies management, and different organizations which could have to intervene in case of an issue. So all of these are sharing data and needed some model for that. A second example that I like because it's in cooperation with India, where we are deploying a number of different use cases again over the water life cycle. You see on the left in Guwahati, quite big city in India, where they're deploying the water distribution network, because today it's everybody who has to make his own hole to get water. The second one, which is about tanker-based water distribution system, so it's really a truck which is distributing water from place to place, but also some of on irrigation or groundwater surveillance and new approaches for wastewater treatment. And there, an interesting aspect of that project is that also we are developing and transferring a new sensor which is based on carbon nanotubes, with the aim to reduce by a factor of more than 25 the cost and the size by a factor of 10. See on the picture, the sensor is 25 millimeter in diameter and can measure today it's about 10 different chemical species. So it's quite advanced. So what's interesting in all these projects, we saw already that they are sharing some common interests on data models, but also on the architecture. So when we try to put things in common on all these models, it really comes out that all is about context information exchange. And each time we have the data producers on one part, which can be the sensors, whatever they are, but the others, more general data, open data, social network, and so on. We have obviously all the data consumers, which are the dashboards, the applications. And in the middle, or around that, we have all the data processors. So we can think here about models, such as machine learning models or AI models, or more advanced topic like digital twins, which is attracting more attention to. And for that, to exchange all this information, we need in the middle this context information broker. And there, obviously, there are a number of initiatives which exist to exchange data. That's something new. But what we need really in this domain is to be able to have interoperable interface and open interface. And when we say open, we're not speaking about open API, because all platforms are saying, okay, I have an open API, so I am open, but in general, it's made by one organization, so it remains a proprietary interface. And here the idea is really to build upon standardized interface where European actors, HC, is in place to do the standardization, and at the same time having the open source ecosystem, which is what the FIWARE Foundation is organizing. So with these both entities, then we are able to progress on that thing. A real life example of what is running today. So this is coming from the FIWARE for Water project. with several partners there, EGM, but University of Exeter as well, plus Southwest Water, which is in the UK. And the other idea is to have, they have a number of smart meters, about 100 smart meters, which are connected over a Sigfox network. And what we've been doing is that we are collecting this data to a FIWARE platform. So for that, we are using a component which is called the Sigfox IoT agent, which is able to get the data from the Sigfox network and pushing it to a context broker. And there we use the Stelio context broker, which is provided by EGM. Attached to that, because it's a water distribution network behind, we connect the EPANET water network simulator. So EPANET is widely used worldwide. It's an open source product which allows to provide pressure-driven or demand-driven simulation of our water distribution network. And this is being connected to the broker with the idea to provide features like predictive analysis of what is happening in the network, anomaly detection, that's something in the network is happening which is not aligned with the model, for example, and to also run what-if analysis. And data produced there are then consumed in a three-way. Obviously, we have the web app or the dashboard for the utility manager, who is able to have a look on the status of the network. We have the interface of the EPANET system, where we see relations between the system on the field and what is from the EPANET simulator. And there is also mobile applications from Southwest, which is being used by the citizens, the customers, to also help them tracking, monitoring what is the water consumption, and being able to optimize the water consumption by comparing, for example, what is the average of the others and this kind of things. So this was to quickly illustrate the way we are progressing the use of this open standardized solution in the water domain. So several research projects working on them, grouping efforts in both modeling the data using the same interface, and all together progressing to define all across a number of use case and the real field. So if no further questions on that, we can proceed to the next presentation, will be done by Alexandre Chaffotte from the city of Saint-Quentin, and he will show what is being done there in the city regarding irrigation or smart irrigation for the city. So Alexandre, the floor is yours.
Hello, thank you. So, so basically, I present myself. I work for the city of Saint-Quentin, and I am mainly I would say a customer of digital technology. So I just want to share my my experience as a customer, and my experience is based on developing a modernization of our watering system that we have in Saint-Quentin for the watering of stadium. So starting point was 2 years ago. We established a top list of local challenge that we can address with data based on the feedback of stakeholder. And so one major stake to address was the need expressed by the Green Space Department to modernize the management of stadium, the management of maintenance operation on their stadium. So it's mainly a question of watering and mowing. So the department needs are very simple to understand with two objectives. First, make water consumption more parsimonious by adapting it as closely as possible to the real water needs of the grass. In fact, it's about for them to remove two recurrent problems they identified. One is overwatering of the soil, and second is a difficulty to maintain a sufficient humidity level all the time. And the second objective is to make the maintenance operation more autonomous, thanks to a remote system that send instruction and coordinate the action of the different equipment that we can find on the stadium in Saint-Quentin, like sprinklers and lawn mower. So the benefit associated to this objective for the green space department are: one, reduce water consumption, and second, save time and suppress daily travel, as there is no more need to go on the field to program operations. So the second step for us was if we want to implement a solution that matches the user need, we need to satisfy, in fact, a long list of technical constraints and that we have identified. So first, we need to define a watering strategy based on the real water needs of the grass. And to quantify this real water needs, we need to develop an objective measure of the soil moisture with IoT device. We need to match up this information with other environmental parameters like weather forecast or evapotranspiration modeling. And last, we need to have an application to get all this information of the current status of the stadium. And insight on the operation we have to carry on, like decide the watering strategy and organize the sensor maintenance. The second element is if we need to gather additional information in order to identify an appropriate slot to apply the watering strategy. So to do that, we need to connect to be connected with the IT/CT system to collect a data set like mainly, for example, a planning application of the stadiums. And we also need to determine a sequencing protocol to trigger the sprinklers one by one, because in Saint-Quentin the pressure of water is very low. So it's one by one. Third, we need finally to apply remotely and automatically the watering strategy. For us, that's supposed to connect the watering solution to the incumbent irrigation system in order to send to it the instruction, and also verify that this one are effectively applied. And also we need to connect the watering solution with the lawn mower to avoid potential conflict with the sprinklers. So for us, the third step, in fact, we led an experimentation to define the digital infrastructure needed to satisfy the long list of technical constraints. So it was there was two elements. The first is we conducted a learning by doing process with a local startup called Element.io in order to co-develop with the user of the green space department the two layer of the watering solution. So this is the IoT system that provides the objective measure of the water needs. And second, the application to get information on the current status of the stadium and insight on the operation. So watering operation and sensor maintenance. The second part of the experimentation was mainly a parallel cooperative agreement with two technical partners of the city of Saint-Quentin, mainly the Faubourg Numérique, local FIWARE hub, and also the telco Orange. And the objective of the agreement was to specify the digital infrastructure needed to support the integration of the watering solution and its interconnection with the rest of the city infrastructure. So as previously mentioned, IT system, incumbent irrigation system, lawnmower. So this part was very important for the city because it allowed us to leverage learnings about technical and organizational aspects needed to implement the city as platform concept in real. And so after the fourth steps was we made a public tender this year to move from prototype to large scale solution. So for this tender, in fact, the main challenge for the city was to answer this question: how to procure a fully interoperable solution, because the prototyping phases highlights that interoperability is the key for successful implementation. Indeed, the watering solution will produce a low added value and will not run at its full potential without a platform that allow us to aggregate, compare, merge, and reuse data from coming from heterogeneous source and system, as mentioned previously. And it was a really huge challenge for the city because in fact, we don't have no previous experience now with data platform or IoT question. So to face this challenge, we leverage main insight from the technical framework of the Synchronicity project. It's a large-scale pilot on IoT led by European Union. So the main features we put in our public tender are first, we shaped the public tender around a central core, the context broker, in order to monitor access, use, sharing, and management of various information from various systems and sources. Second, we asked to all applicants to be compliant with the NGSI LD standard that will serve for us as a common language shared by all the components of the solution. Third, we asked for the provision of some connector that will serve as translator, converting some very usual format like LoRa into the NGSC LD format. And last, we establish a clear separation between the technical component specific to the watering solution, so the IoT device, and the application. And the second part was the data platform that was separated. And for us, this separation aims to avoid some vertical solution totally integrated, and also potential risk of vendor locking. The interesting fact about this public tender is that for me, the market seems mature for procuring such a solution based on NGSI LD standard, because in fact we received a sufficient number of good proposals based on this standard. So it was a good news for us, because we was not sure at the beginning to receive many answers. And the first step now, just a picture of the overall architecture we will deploy on the 9 stadium of the city of Saint-Quentin from 2020 to 2021. So in fact, you can see the multiple layer of the solution. The first is a southbound layer with a sensor that allows us to monitor in real time the soil moisture on the parcel forming a stadium. Actuator that allow to start and stop the sprinklers. The lawnmower we have to connect to. We have also the northbound layer, mainly the remote management application that allow to monitor stadium status and manage maintenance operation remotely. And after, we have also to connect with other external open data sources that are mainly coming from the city or other providers. So it's the planning occupation of the stadium and some weather forecast. And at the middle, we have the layer that with the data platform built around NGSCLD context broker and some extension like a connector to communicate with data in other format, data storage path, and module to visualize data. So, and to conclude, I just want to say what's next for us after the deployment of the watering solution. So the final consideration for me is that we spent a very big amount of time to define these digital architectures. So that we need to support the watering project. And it will also represent a certain amount of money to deploy and run it. So for us, it makes sense after to replicate this framework and reuse it for other projects in order to realize economies of scale. And as the entry cost was very important at the end, it will never be cost effective for us to use this framework and digital infrastructure just for single use case. Just to conclude, I want to say that this digital infrastructure in fact was designed to be independent of use cases. So we can imagine plenty of extension to various domains in the future. I have put some example on domain we want to explore after. So it's done for me. Thank you.
Thank you, Alexandre. So I don't know if there are any questions. We can take some, if any.
Hi, this is Antonio Skarmeta. So just one question. I already saw that in your presentation that you already have several sensors based on LP1 being deployed on the city. It is also the city managing the LP1 network, or how you manage this? How you integrate this data in your infrastructure?
LP1. So in fact, as we are not many huge quantity of sensor, we use a public solution. We are not ready to go private network. It's not interesting for us, but perhaps in the future, but no, not.
Okay, thanks.
Okay. So thanks a lot, Alexandre. So our next speaker will be Mr. Thomas Grünig, who is Director of Marketing and Sales at Systemtechnik, and will present about smart city network.
So good afternoon, everybody. This is Thomas Grünig from HST. I am responsible in our company for the international business. Welcome you to the water session to the Green City conference this afternoon. So my topic today is the water smart city. And before I dive into the real stuff, I would like to present the vision. What makes a water smart city? A livable city is where people enjoy every moment of the daily lives, where they committed to their future within the city. An attractive business environment for skilled laborers, investors, and of innovative business. An intelligent, interactive, and responsive services, no environmental impacts. We need optimal use of the resources, and finally, also especially also for cities like in Malaga, iconic smart city for living, working, and tourism. So if this is your mission, then create an autonomous water cycle. That is actually what it is all about, an autonomous water cycle where abundant water sources are available at all times, where there is no threat for flooding, where the wastewater and rainwater is turned into precious resources and entirely retaining in the urban water cycle. So that means create an efficient, resilient water network for wastewater, rainwater, and freshwater. And finally, this needs to be done with a smart governance, by applying innovative technology and IoT concepts, doing adaptive water and wastewater management, make it from a reactive operation to a proactive activation. So how to fulfill this mission? So if you look at water infrastructure, so we have quite a number of objects in this network, like waterworks, sewer networks, deep tunnel collector channels, wastewater treatment plants, pumping stations, deep tunnel collector channels, and so on. So usually in a conventional system, these objects, they working independently from each other. They just are controlled by sensors that are sitting in the objects, and they're running and operated just by these local sensors. A very major impact or parameter for such systems are the precipitation. That is an outsourced parameter, the cardinal parameter from outside that influences all these network and the drainage network. So now our concept of running a water smart city is to connect all these objects with each other. So they are depending somehow also of each other. So the pumping stations, the deep tunnel collector channels, and the wastewater treatment plants, they interactive with each other. They're depending on each other. And our concept is to exchange information among these objects. So that means they talk to each other and exchange information. This is done by using the cloud, and all the information are combined in a software called IntelliNet, and through the head station of the system, the information is exchanged between the objects, and also they're using information from outside through IoT. So why is network objects and network management very important? And the answer is because of the peaks in the system. Usually, if there is the loads of the system is equal, then it would easy to manage. But the peaks, the unpredictable peaks, are the challenge. And these peaks are, for example, the precipitation. We don't know the wastewater inflow, the dirt load, the COD load. All these kind of inputs are going up and down, and may overload the system. So therefore, we try to convert the uncontrollable parameters into controllable. So that means we control the flow rates, the water levels, and the storage capacity, for example, in the system. And this is being done by smart machines, for example, by flow controllers, by intelligent equipment to adjust the flow rate. It is a flow control based on the programmed algorithm, and we control water levels by, for example, hydraulic weirs, vertical weirs, to adjust overflow levels and flow rates in the system. The collector channels, or every system, needs to have a storage capacity to storage temporarily the excess rainwater or combined sewage water. So this is being optimized by so-called vertical lifting weirs, like laser weirs. The weirs are built in the cascading structure, and they're automatically controlled by special software to utilize the maximum of the existing and available storage volume in a structure. So this is just a picture of the of a real operation in such a system. A second objective of this system is to clean out sedimentation in the tanks, for example, sand, gravels, whatever. If there is a longer period of time, no rain, to flush it out. So these systems are cleaned periodically as a preventive maintenance measure. And that is all controlled automatically by system parameters and, for example, also rainfall forecast information. So all this information and software we combine on one on one management platform. So we call it IntelliNet, where all kinds of software to operate this infrastructure are combined. And they exchange the information. There is a monitoring tool and a control tool to also to receive or to practice IoT, and is a 4.0 solution for the water smart city. So this dashboard contains different software, for example, remote control and monitoring tools to see the condition of the machines, the condition of the objects. It contains, for example, also camera inspection to inspect continuously the condition underground, to decide when and where the maintenance team needs to go underground for maintenance or repair works. Then there is an analyzing tool to analyze the operation of the complete system and to allow to continuously optimize the operation by using graphs and other methods of analyzing and optimization. So this tool has a visualization tool, it's an alarm management, it has a module for predictive maintenance that is consisting of a reporting tool to generate reports to be sent to the management, for example, or the maintenance team. Another software is an operational management software. This is a kind of an asset management tool for municipals, for cities, to plan and to coordinate resources like human resources and hardware resources. This software is also our own development. It is called Carnio, and it has also this planning tool and a mobile solution for the staff in the field, for the service people, to transfer all the site information or the local information directly into the system, and to make available all kinds of documentation they need for their work. So a documentation tool to document properly all the results, and also an evaluation tool that is a management tool to do cost analyzing, resourcing analyzing, budgeting analyzing, and so on, to also continuously improve the operation. So then a further piece of software is the so-called odor and corrosion detection tool. It can predict through a software and through the input of certain parameters where odor may occur in the next future. That means in the sewage system. Yeah? Bad smell due to a little rain, a high concentration of sulfides, and so on, depending on the temperature, the flow condition are considered. So all these kind of information are collected and then calculated, and it can then predict the critical area in the city, and to allow predictive measures to take to avoid this kind of bad bad smell and high sulfide levels. So that is an early and easy detection for risk, yeah, proactive repair and maintenance. And also it is a good reason to protect the health of the service staff. So another tool is energy saving and energy consumption optimization tool. For example, with pumping station, we all know pumping stations are the biggest energy consumption in a system. So this tool optimizes the operation of all the pumping stations to make sure that they are running at the best operation point, the best efficient point at all times by adjusting the speed through the frequency, a frequency controller, for example, or switching on and off the number of pumps. So the application is for new pumping station, but also for retrofit for existing pumping station. And it enables, from our experience, energy consuming reduction of up to about 50%, depending how old are these pumping stations are. And the last tool I wanted to introduce is a geoanalytics tool, or a precipitation forecast tool. This receives meteorological data from a outsourced meteorological company by radar-based, high-resolution, precise radar. So these information are updated every 4 minutes, and it is very precise. So it has a resolution of about 1 by 1 kilometer. So it knows exactly, for example, if how much rain is going to happen in the next couple of hours, 6 hours, 12 hours, or 20, up to 72 hours in the northern part of the city, in the west, in the center. On the right side, you see an example from Oberhausen, city of Oberhausen in Germany. And each of these circles represent one radar information, and we know exactly how much rain is going to fall right now, in the past, and also in the future, up to about 72 hours. And this information then is fed into the IntelliNet system to prepare the infrastructure to the situation that's going to happen in the next couple of hours. So that is a very important tool, yeah, input data for process and operation control, but also for planning processes. So finally, just also to introduce where the data, what are the data sources? Data sources are sources from the system itself, internal information from the sensors, from the SCADA, from the process control system, but also from the internet, you have this meteorological data, or from any kind of open data, ERP system, or external data. These data from the system, together with the outside information, the IoT information, are put into, yeah, we can say, in a funnel, and the IntelliNet software is fed with this information. So that means existing information and outside information, and through configured algorithm, there will be then decided what is happening, what needs to be done, when is it happening, where, and how much. And then this information is then transferred in actions of the equipment, the mechanical equipment that sits in the infrastructure, like weirs and gates and cleaning systems and fine screen systems and so on. So they control and calculate the best way of operating it. And this information then is monitored and displayed on the dashboard in one site. So all the information of monitoring, of analyzing tools is all combined on this kind of dashboard. Okay, so that is just very brief introduction of this concept. So finally, I want to say this water dashboard should be and is an important and integral part of the overall smart city dashboard. You know, we have traffic, weather, events, energy, whatever, and the water infrastructure is one very important part of it, and it contributes certainly also to the Sustainable Development Goals of the UN. So we, I think this system can contribute significantly to life below water, the sustainable cities and communities, and also for the sanitation system. So we have executed this IntelliNet software, at least also parts of it, in Frankfurt, in Germany, for example. We are in the course to introduce part of it also in part of Shanghai right now. We have done it in Austria, in Innsbruck already. Yes, so it is a software and a concept that is further development, so that is now in full swing, and and it is tailor-made for the needs and for the operation demands of every city. So our company has been doing this, or is in this business active since '81. So we're doing mechanical equipment, automation, and a major part is IT and IT software. Okay, so far that's then my last slide. Thank you very much for your attention. And if you may have any question, please feel free to ask them.
Yeah, one question on my side.
Yes, please.
Is your system connected to the other domain, the city, energy, transport, and so on?
It can be connected, yes, integrated in the overall system, yes.
For that, you have some specific interfaces, kind of interface?
That is completely open. We can realize more or less all the interface. So if it's not available, then we just do this, develop this interface with whatever is necessary.
Thank you. So because the water in the city should not only look at the city, but also around our next speaker will be Professor Antonio Skarmeta from University of Murcia, and he will present about the water management at the basin level. So Antonio, the floor is yours.
Thanks, Frank. So first of all, thanks for the invitation and to come here to do this presentation. What I was saying is, first of all, thanks and for the invitation. And in this case, I have two different hats. One of them, as already was mentioned, as I'm a professor of the University of Murcia, where I'm basically focused on computer networks and communications. But also we have a part of a spin-off company that is called Odins, where we are doing most of the technology transfer, I would say, from the research results that we are having as part of the university work, in that sense, where we are quite focused on the area of IoT and specifically on a scenario for smart infrastructure that are in some cases, I mean, agriculture, but other one are water management and also transportation and this kind of stuff. So basically, what I wanted to give you today is a very brief and broad presentation where you can see different scenarios that already we are envisioning in the area specifically of the water, but in the water from the point of view of not water distribution, but mostly about the water management that is being applied in the case of at the basin level, but also at the plot level in that sense. So in the sense that trying to cover basically the whole water cycle until finally it is being used for the agricultural sector, I would say, in some sense. So this is basically a result of also of different projects where actually we are involved in that sense. One of them is two of them are in the area of European level. One is Demeter, that is one of the digital transformation in agriculture big project that already is ongoing. Other one is in this case a WaterMed, that is more focused, is a Prima project that is more focused on the Mediterranean area, specifically on several countries on the Mediterranean area, in order to improve the use of the water on different aspects, not only agriculture, but also I already mentioned, for example, for the quality of the waters and this kind of stuff. And then we have a one regional one that's called Rusagua, that basically is focused with different, it's very multidisciplinary with different people from different fields, where we are trying to understand different problems that are affecting the use of the water on the agro sector in that sense. So one of the key issues that all of them, and in all the case has happened the same, is that up to now, I would say up to now, this sector in some sense, in general, has a lot of issues regarding the integration of the ICT in that sense, specifically because in many of them, they are working with very, I would say, a close solution in some cases. There's completely lack of integration. I mean, most of you already have that experience. That there are different products, but basically they are not able to interoperate, etc. It was quite nice in the previous presentation that in the other way they were talking about their capability to be open and do interoperation. I think this is the trend, and this is something that we need to have more on the sector. But in any case, more and more the situation is changing. Obviously, one of them is because thanks to IoT in some sense also. IoT is pushing on the direction to facilitate basically the protocol that allow the integration, I would say, of the at the sensor and the actuators, not only in the sensor level. Also because more and more open interfaces are appearing that allow this kind of interoperability. And I think that two main, I would say, elements that already have consolidated these trends, as is one of them is solution like FIWARE platform, in that sense that has been quite extended over different project and either commercial products in the sense. In our case, for example, in Odins, we are using really FIWARE as a component and enabler basically for our real solutions. And also I would say clearly the use of quite accepted, I would say, or more generalized de facto standard for that interoperability, like for example NGS-ILD in that sense. In our case, also we are quite interesting, and we are using it on different proposals and projects basically in order to try to facilitate that interoperability. In that sense, for example, and just to mention related to the previous presentation, one of the collaboration that we are doing with the smart city of Murcia, for example, where one of the main characteristics of the project has been to force that any possible company that is going to collaborate on the ICT sector, they should go to a standard like this data interoperability through NGSI in that sense, and obviously and NGS-ILD also as another alternative. But anyway, the main idea here is that we are, I was trying in some sense to understand that all this is creating this a momentum that is facilitating the possibility to go ahead on all the integration on the digital to the digitalization of this sector in that sense. So just to give you an idea about, also because of the complexity, as I already mentioned, regarding this connection of all the cycle of the water that could be affected, and where we are trying to push on the direction to have, this kind of platforms that are interoperable, is the scenario of the Prima project in WaterMed. In that sense, that I already mentioned, is basically focused on to improve the quality and safety on the Mediterranean agriculture, and basically focus on semi-arid areas, basically because all the countries that we are involved here are in this kind of condition in that sense. So basically, the main idea is to be able to create a solution, in this case, an architecture that should allow to have different kind of layering, if you like, in that sense, that go from the management of the sensors through some kind of virtualization, I would say, of the IoT devices, but also to be able to have some kind of data models that could be shared that facilitate the definition of different kind of management and data analytics over this data that could create a collection of services, as you can see here, on different aspects of the life cycle of the water. So the life cycle here of the water, as you can see in the upper layer, is not only for the irrigation sector, but it is to understand from the sources or the reserves, that could be the dams, could be the rivers, etc., where we can get information about the situation of the water, the quality of the water, up to the obviously the distribution of this water over a collection of areas where this water is being used with different kind of in some case mixing water from different quality that are being from different areas, I would say in some sense. And finally, how this water should be finally distributed and be used at the plot level by the agriculture in order to provide some kind of a water irrigation procedure, where obviously we need to try to optimize all the process. But it's not only just optimization, as I already mentioned, it's also to take into account the impact of using this water depending on the source, where this water is coming from, what has been the effort to transfer the water from the source up to the destiny, and so on, and be able to identify how all these elements and variables are taken into account in order to take the most appropriate decision. Because at the end, what the main objective is to have like a governance model that allow us to take the most proper decision in order to have to help the end user, that in this case are the agriculture, to decide how to use the water on their plot, I would say in some sense. So as you can see here, there's a lot of different elements that need to be monitored in some sense, need to be sensed and need to be integrated on the platform in order to collect information and manage all this information in different ways depending on the kind of problems that we need to take in consideration in that sense. So for doing that, basically, here you can see similar to I think previous presentation that already have been done and regarding different usage in that sense. We opted from the beginning to follow this kind of interoperable platform that allow to create layering that are able to facilitate the distribution of the work, and also to create standard interfaces between each of them, I would say in some sense. So basically, most of the scenario, as you can see here, we are using different technology. Obviously, we have the sensor at the field level in that sense, or in the field level, or for example, in the case of the dams, or in the case of the different points where the data is being collected. All this, we are using different technologies, obviously, because in some cases, it's possible to use local solution, but in other case we need to use a solution like LoRa or narrowband LT, or in this case, or any other technologies. Also, we need to take into account, as you already mentioned, that we, in some cases, what is important is to be able to really talk with legacy systems in that sense. For example, as you will see later, for example, we already, in order to get information about the water distribution, we need to connect with the pump, with the SCADA system that is already being in place and is managing all the distribution of the process. So we need to get the information from there that should be aggregated to our platform in order to use it in combination with the other sources, so that we can take decision, make analysis, do prediction, etc., etc. And basically the next level is to homogenize basically the modeling of the data model. So for doing that, obviously all the data has been integrated in brokers, in this case data broker like NGSILDs, and we already are going to, as you will see later, we are working on different kind of data models that we are using for the extending, I would say, the ones that, for example, FIWARE has proposed for different sectors, in order to cope with the specificities that we can have on our scenarios in that sense. And basically at the end, everything then goes to the platform that later is able to do some kind of analytics, or could do some kind of processing of the data in order to integrate this with information like geographical information system, open data that is already available, so that we can really have a big the option to increase, I would say, the information and then generate new knowledge based on all this processing part, I would say, in some sense. Here you can see, for example, one of the scenarios where we also, and you can see some examples of the kind of wells that we are taking in, reservoirs that we are getting the data. For example, this is specifically an irrigation community where we are considering as part of the piloting. But what is important, as I already mentioned, is that we are not just taking information from sensors that we are able to deploy in some case. For example, we have 2 different weather stations that we already have deployed on that specific area that complement the weather station, for example, that are being offering data on that area, but also that we connect to the SCADA system that they already have. That's it. So that we can get from third-party information about information from the reservoir, from the wells, etc. So that we can integrate all this information through a corresponding, in this case, agent, so that we can, in this case, integrate the information apart from the information that we are getting from our different sensors in that sense. For example, in this case specifically, it's important because we want to have a water quality analysis that should be received by different points in order to decide later the quality of the water, and based on this, how this is going to be affected in this case, the different crops that are going to be using that water, or to stop to use certain kind of quality, certain kind of water in case the quality go below certain threshold, for example, and then they can use another one or do a mixing, etc., etc. Specifically here, it was quite important to do this digitalization. Here you can see just a very simple example before any of the solution that we already bring to there. This is for a specific crop, where you can see without putting in place the solution, we just monitor the system, and here you can see an example of 2 situations where basically the irrigation of the system was quite inconsistent, basically with the needs of the field in that sense. So in some cases they were putting more water than was needed. In other cases, it was totally the other way around in that sense. So at the end, as I already mentioned, it's important to facilitate this information because it gives a lot of hints about how issues are happening on the fields in that sense. As I already mentioned here, one important thing is at the end, as I already mentioned, is that we have integrated from not only from the sensor that we already use in the field, as already mentioned, the SCADA. We are using obviously also additional information about open data, and also other information that is being provided by the customers in some sense. So basically here, many times the owner, in this case of the plot, or either the management, persons in the communities, they are already being able to provide additional information that because of their expertise that help us in order to add this information to the system in order to take a certain kind of decision in that sense. So at the end, as I mentioned, the idea is that also one of the important things, for example, here, and this is a sub problems that we already are working with them, is to try to optimize the use of the pumps that they are using in order to extract the water. So because at the end, as I already mentioned, also there's a problem of economy in that sense. So you can use certain water, but also depending on the cost of the water in that sense, specifically in areas like Murcia and others that are quite dependent of an inefficient management of the cost in the production. So one of the points here was to try to understand when the different pumps, depending on the condition, maybe could be inefficient and maybe are generating an increase of the cost of the water. And for that, maybe there are another alternative that can be used from wells or from other reservoirs in order to be used in order to reduce the general cost of the production in that sense. And for that, as we already have need to model, and we already have done a model of the system, and we have used it in order to do this kind of optimization. The other issue about the modeling that I want to mention that is quite important is the modeling of in this case of the field on the plots. So in that case, we are working in that sense on an extension, I would say, of the models that in FIWARE have been proposed for the agriculture in that sense, in order to take into account different aspects. For example, here you can see the extension regarding the different kind of crops, the information about the zone, about the phenomenology, so the situation of the crops, because that also is affecting how we can do the the generation of the different decisions that need to be provided by the platform in that sense. And this is, for example, what going again to the water met. So as a complete system, you can see here in the previous and the following slide, you can see the amount of different data, if you like, that we are using. In some case, data that are being provided by different sources, like could be the as I already mentioned, the weather stations, satellites, for example, that we are using in order to integrate with the information of the fields in order to try to understand how the evolution of the fields, all the information about the sensors in the plot, you know, so water counters, water electrobubbles, water soil mixer sensor, etc., etc., plus information that the end user need to provide, for example, irrigation plan, any historical data, for example, that they already have from a previous years and so on. And then the same way here, you can see, I mean, at the end, what the outcome that is going to be generated for them is just to decide how will be the different information regarding their irrigation planning based on information that also the user should provide about the kind of parcel that they have, the crops, soil, and additional information that we can bring from the system. At the end, what we are trying to do here, as you can see here, this is just a snapshot of different functionality, is to provide them with the system in that sense that allow in some case, not necessarily the end user that this is the agriculture, but basically all the persons that are in charge of supporting them for example, in the community that they are part of, in that sense, in order to get information, as you can see here, that provide them support in order to take decision. So you can see here either from the satellites and how it's the information is being provided by the different weeks. In that sense, weather station that I already mentioned that in some cases are directly on the plot, in other cases are one that is near to the plot, and obviously. What I was saying is that one of the things that we already have done not only in WaterMed but also in other projects is to try to reuse, in this case, the data models already being proposed. In this case, extending them with the needs and the functionality that is required on the different scenario. For example, here you can see issues regarding the different types of crops in the area that's been applied. For example, the phenology aspect that allow to indicate the evolution of the crops over the year, etc. So it's something that facilitates us to take decision on the different possible application of the solution. So just to mention that, for example, here you can see the different kind of information that we are getting from different sources, water. Information coming, or not water, but also water, soil information, conductivity, temperature, weather location, local sensors, all the aspects that are provided also by the weather station, information about the data analytics, historical data, etc. And all of them are bring it and integrated on the common data model. In this case, as a different NGSILD entities that later are being used for taking the decision, for doing the prediction, or to do some kind of analytics, as you will see later in that sense. Here you can see also the kind of input that the user is able to provide, because we provide the front end so that they can also provide information like the parcel location, so that they can use some kind of geolocation information there, the kind of crops, etc. That they already are having, and any other additional information that we can bring from their specific plot, so that they can integrate inside the model. At the end, what we are offering is like a collection of services, as you can see here, information that allow them to see what is the evolution of the crop, for example, uses satellites, the information about instant information about the weather information, weather service that are being provided inside or from the nearest weather station, and obviously all the information, historical data about all the sensors that are being sensors and actuators that already have been deployed on the field in that sense. At the end, what we want is to provide, as already mentioned, not only the collection of data, as you can see that is in the blue side in the upper part, but also to do some kind of data analytics that allow them to, in some cases, are more I would say, statistical analytics about average, maximum, minimum information for the certain periods, etc. We also have this management of the satellite information through different kind of index, as you can see here, and also then used all this information plus the from the information from the user in order to do some prediction, for example, estimation of the Aitor evapotranspiration value, for example, that are key in the decision of the irrigation and the amount of water to be used for the irrigation planning. For example, in other case, we are talking about water balance models associated to the quality of the water, and also that they are using on the corresponding fields, I would say. Okay, so at the end, I mean, this is just another example of the kind of prediction. So at the end, what we want is to be able to use all this collection of information in that sense that are coming from the data, from the soil moisture, coming from the analysis of the evolution, etc. Information about how is the impact of this value on the geographical information system, and with all of this, being able to do some kind of prediction. Taking into account the evapotranspiration calculation that we can get with all this information. So at the end, it's a service that help in this case, either the agricultor or the expert that are providing advice to the agricultor about what will be the strategy that they need to have in order to have their better management of the plot in that sense. Taking into account not only, as already mentioned, purely agricultural data that is like this one, but also the other information that we are mentioning in the other case about the quality of the water, about the sources of the water, etc. That also have an impact over the economic decision that they can have on their different scenarios. And finally, just to conclude, just to mention that this kind of solution that we are talking here in a more big scale level is what is already taken considering part of the Demeter. That is quite big. I was a project covering different fields, but also the integration of much more, I was at data coming from different contributors, I was at in some sense. Where basically here the main idea is to create this decision support system or service that should be able to provide a collection of different kind of, in this case, of a marketplace in order to facilitate through the interoperability aspect to be able to create your own, I would say, profile of services, depending obviously on the use of a common data model. In this case, a data model actually is what they call the AIM in that sense. As you can see here, that at the end is also connected to the use of NGSI LD as a baseline data model that will be obviously enriched with different combination of, as previously Aitor presented, with the use of ontologies, Valais or maybe other alternatives also that are being considered in that sense. Okay, so just to conclude, so from me, I think we have a big opportunity as I start from the beginning, where the use of IoT platform, the use of these data models, and the possibility to do this kind of interoperability mechanism will allow us really to support big scenarios in this case, as we have just mentioned, as you can see, for example, in the case of WaterMed, where we are bringing a lot of information from different sources. So aspect like scalability, like heterogeneity, basically, of the information and how everything could be integrated, merged, and be used in order to increase the possibilities of the solution being defined will be clearly one important result in the future that will allow, as also we mentioned here, a great of dynamicity, I would say, in the possibility of creating not only data models but also the creation of new services and new facilities for the sector. And that's all from my side, I would say.
Okay, thank you, Antonio. Do we have any questions for Antonio? No, I have one for you. Well, when you are working at the basin level, Antonio, I see that you are doing some local optimization, but have you considered the use of models like water flow?
Yeah. Yep. Indeed. I mean, I mean, I didn't mention it very clearly there, but I mean, as part of this governance model that one of the partner in WaterMed is proposing. They are also considering this kind of optimization approach in that sense. So It's similar to what you mentioned regarding the EPANET on the city level, I would say, but more at the basin level. Specifically taking into account, as you already mentioned, the idea of how to combine the different water sources with their cost of extraction in some sense, because in some cases also they are considered, for example, desalinization water in some specific case, and how all these elements taking into account also the distribution, the effort, for example, or the energy that goes to move the water from the sources to the corresponding destiny, how to try to optimize out that model so that they can provide, I would say, some kind of solution that represent the most effective from the economic point of view, and also based on the needs of water of the plots. So because at the end you need to cover the plot's needs, but trying to optimize how these needs can be covered with the different combination of water sources and distribution process, I would say. So it's quite a complex, it's a multi-objective problem, basically, that need to be addressed.
Okay, thanks a lot, Antonio. We move to the next presentation. So we have been looking at some use cases for smart water management. Now we are going to look a bit more into the details and looking at the specificities of data modeling for the water domain. And we will start with Aitor Corchero from EURECAT, who has been a contributor managing the development of the SAREF for water ontology in the sea. Aitor, the floor is yours.
Yes, thank you very much. I will put it in the presentation. Yes. So during this presentation, we are going to talk about the link between SAREF for water and the FIWARE context in order to improve the interoperability in water domain, but also at cross domain. So my name is, as Frank said, is Aitor Corchero. I'm researcher at EURECAT Technology Center, and I am also, as Frank, be part of the ICT for Water cluster, leading some action groups, and also we work with Frank in the cross synergy working group that we will present at the closing part of this presentation. So a little bit as outlined, we speak about the context and why we would like to link SAREF for water and the NGS-ILD data model. For that, we also see the problematic, the brief history, also a little introduction to FIWARE, the same for SAREF for water, just to finalize with example of the mapping between SAREF for water and NGS-ILD models, and finally present the conclusions and the different future work. So the main idea behind how data integration and also the more data interoperability is in terms of we are facing in the smart cities with different infrastructures, and we are living, as in the previous presentation we saw, that there is a energy infrastructure, that they have their own smart meters, energy meters, smart grids, and some kind of real information. And the same in the water domain, that we have smart baths, smart pumps, and also we are facing with drinking water, wastewater infrastructure. Also, we could include it agricultural water infrastructure, watering, and also combined with industrial waterings. And at the end, we have a lot of systems installed in the city that we need to integrate data in order to take better decisions, to create new dashboarding tools, and also to tackle decisions. But the most important thing is that most of these sectors or domains work in silos, both internally or even at cross-sectorial level, and this could create a limitation of the decision making. And for that, we need to create water data interoperability and more explorable tools in order to link the domains, the information, in order to better understand the domains and create win-win strategies. Considering this, well, the main problems could be summarized in these 4 bullet points, that are the high fragmentation of the sector due to the lack of communication between the different systems and derived from the different standards that are using the smart meters and the smart tools that are on or spread out in the smart city. This high fragmentation of the different sectors due to the multiple standards creates or generates or derives in lack of cross-domain creation of digital services due to there is no a clear proliferation of one standard, there is no a common vocabulary, and as we talked also in previous slides, we need to create tools that permit to create common vocabulary openly in order to promote the data exploration, consumption in a common way for diverse tools. This could also be linked with the creation of digital architectures, different reference architecture or different digital architecture for consuming data, for performing analytics, for performing or showing digital services, and this creates or motivates the creation of the well-known reference architecture of FIWARE. And finally, all of this is done one more motivation, that is to create with the business models. So there is no clear business models right now, or we're trying to face this challenge. In reference to we are collecting a lot of data with different sources, but we are not exploring all of the data potential that we have it stored in different databases due to there is no clear vision of how to create business opportunities about this data. And FIWARE, common data model, semantic interoperability goes in this way in order to minimize and to promote the creation of tools, digital services that could help people to better understand, for example, their consumption in water, or how to make predictive maintenance in the water infrastructure and they save money or create a business opportunity in the different sectors, even in isolation regarding water, but also at cross-domain using the combination of how to create winner-winner strategies, for example, for the water or the energy domain. So in this image, it's a little bit of overview of the standards for the water domain, and there is a huge landscape in the IoT association that show all the standards for all the different domains. That there are a lot of standards that the implementation of these standards are in all the domains, and we need to create common umbrella in order to integrate data, exploit this data, and create digital service about this data. So a little bit of story regarding the water and semantic interoperability is this small picture that starts with in 2010 more or less with the creation of proliferation of inspired data models, and also projects at the Euro level that tries to promote the interoperability between the systems in the water domain, and for that they use it the well-known SSN ontology. This kind of initiatives derives in parallel with the creation of the Open Geospatial Consortium standards in 2014, more or less, and that creates common data model for the water domain that is currently being used. And this also, the SPIRE directive and the SPIRE data modeling derives in Sandre reference architecture, more data modeling regarding SPIRE that also creates or gives the opportunity for the semantic water in the creation of HI features, water semantics, and other specific ontologies. But as always happens, and same with the standards, occurs with the ontology domain, that there will be creating a lot of ontologies that there is no longer maintained, and there creates the motivation of the challenge to create different ontologies for the different domains that could be under the same umbrella, say long-term maintenance. And for that, during these past years, the trend goes to the creation of a SAREF or adaptation of SAREF semantic model into a broad of domains, and ETSI creates the standard in terms of SAREF. They create the standard of NGS-ILG and also this reference architecture to collect data and expose this data to a common data exploration and consumption. So this presentation, we will talk about FIWARE reference architecture, because a reference architecture at EU level permits to share data across domains and elaborate new digital analytical services and assets. This means that we do not need to reinvent the wheel in all our projects. We just could use a common infrastructure being developed that could permit us to integrate data for a broad of domains, permit us to create architecture layers to elaborate our own algorithms. Big data algorithms are also the same for creating digital services, APPs, or even dashboarding tools. So the main benefit of using for us in the watches domain FIWARE architecture is just to focus on how to collect data, how to analyze, find patterns, how to create algorithms for this data, how to share different algorithms, different information from different domains, and how to share different applications under a common framework. And the same way in this, as explained in the previous presentations, there is a specific module for data integration that is the context broker, that is a publication subscription mode, and they, well, in the line of data-driven context broker, that means that based on the JSON-LD model that defines all the things that we want to integrate, we could create these message brokering tools and then collect information and expose it openly to different applications in a common way and under a common REST API. So in terms of data modeling, we have been talking about two big models that are under the umbrella of HCI. That is, on the one hand, is the SAREF for water ontologies and the cross-domain ontologies, but also the existence of the GSILD. And the main motivation is, well, we have a common model, and wide-use model for the IoT and for the data integration, ingestion, and as it is in GSILD, but also we have a model that creates some descriptions of the water domain and how to measure the things too. So the main intention is to combine these models and also to provide common descriptions of how water physical digital devices they have to create or enrich the GSA models, also to expand it to the use of the ontologies and semantic models and the JSON LD, and also with fully compatible both models, the part of people who prefer to represent models using semantic modeling, or the people who trends to more NGSILD, so we can integrate both kind of data. So the main intention objective of this mapping is just to harmonize both NGSILD and self-for-water vocabularies with the aim of finally offer through the APIs of the context brokers this information about this information in form of serialize it in JSON and LG. For that, we would like to present a little example of how to perform these mappings. In this example, we could see a tank that monitors a specific system that also connected with a specific sensor of temperature sensors. And here, this common modeling in NGSILD with the different temperature measures, with the different specific values and also units. And we need to also try to provide a common link with self-for-water. So the strategy that we follow up was firstly analyze, understand NGSILD vocabulary. After that, we analyze SAREF for water in the first version, but now in the release version, also align terms between the both vocabularies, and then implement it and create a context for ingestion LD for performing this mapping. So at the end of the process, we have this combination in terms of we have it a tank that is an entity in NGS-ILD, but also it could be in the different types, a fish containment in for water that combines to a water asset. Also, the different relationships in NGS-ILD could be transformed depending on the relationship between specific relationships in for water, for example, in tank 1 monitors, it could be transforming have subsystem relationship with a specific other system, and also the terms of a specific measure could be as a has measurement, and a specific unit as has unit, or even a specific timestamp could be transforming has timestamp. All of this process is kind of depending of the specific data model that should be defined. And at the end, we have a JSON LD model. This JSON LD represents an ID with a specific name, but for example, in the type tag of NGS-ILD, we could add a SAREF or linkage with a SAREF as well as NGS-ILD. And for the measurement of the different properties of depth or temperature, we can include the NGS-ILD property, but also SAREF for water property and measurement. And in the specific relationships, also we can link the specific relationship with the SAREF for water, just to make it compatible in both serialization in JSON LD. So the mapping generalization has been in a specific context broker, in a specific context in JSON LD. It's publicly available, as in the next slide will show, and we provide the specific tag with the specific relationship in SAREF for water. So by this way of using context in JSON LD, we could link both models of SAREF for water, but also combine it with the NGS-ILD, and also promote the exploration of data using the open API of the context broker, but also we could integrate it in more semantic triple stores just to perform spectral queries, for example, or other kind of analytics. This continues with the part of the geometry, including aspects of GeoJSON, but also continuing with the link of SAREF for water. And at the end, we have published these mappings in a GitHub repository in order to be included in different contexts, or in order to be openly expanded through the different usage and device descriptions that we are handling inside the FIWARE for Water project. So under this presentation, we would like to emphasize the idea of homogenize the information, use the common vocabularies and usage of open standards in order to provide a mechanism to explore and integrate and fuse data from one domain, but also across domain. We would like to remark that data sharing across platforms could be beneficial for taking better decisions, or to create win-win decisions across domain. And also, we are facing the way that all this part of this, all of these descriptions, all of these data models should be defined using different use cases in order to provide a complete interoperable approach. And finally, the usage of knowledge graphs and the demonstration of knowledge graph, we could create more linkable data, and also more ways to explore and to navigate throughout the data using these common ways, this common vocabulary. For the future work in our site is just we have created the initial mappings, and we are trying to collect more examples in order to finally improve this context broker that we shown, and continue with the implementation and create tests and validators for performing this mapping. Just to finalize the presentation, all of this work has been under the umbrella of the ICT for Water cluster, are Franck present in the first presentation, and under this association there were different action groups to ensure and monitor the implementation of the action plan. And under these groups, we are one of them are the interoperability and standardization. We promote the use of the standards, open APIs, and also the usage of common vocabularies to integrate and represent data, as other groups that focus on data analytics, how to share data, how to create business about the application of the digital services, and etc. And also, we would like to describe and also emphasize the work that has been doing inside the different projects that are under the same call of digital watering. And we would like to say here that we are all together under this common vision that we have all facing the how to create or promoting the usage of FIWARE, different data models. Also, we focus on how to create different sensor monitoring tools, how to integrate the data of these, how to create business models around all digital services that we are developing, and also in terms of communication. So this is all from my side. Thank you very much. And if you have questions, don't hesitate to ask me.
Thanks a lot, Aitor, for your presentation. Do we have any question to Aitor? Maybe something from my side, Aitor. I know you are working on other topic on risk management and so on. So do you see relations with SARE for water, or do you see future connection between what I know that you are working on risk ontology versus the water one?
Yes, well, the risk ontology is linked with SARE for water because it was one of the use cases used to define it, and we are now under this digital common working group, just making these mappings also, and also converting this information that we have for risk assessment into ASILD model, just to be shared and to be included into the data modeling in open space that I suppose that Alberto will present in the next presentation.
Okay, so thanks a lot, Aitor.
You're welcome, Frank.
Let's move to the last presentation from Alberto Abella from the FIWARE Foundation, who will present the ongoing work on water data model development, going from the simplest to the much more complex approach, and how this is being handled. Alberto, the floor is yours.
Thank you. Hopefully you are listening to me. Just a brief introduction. I'm Alberto Abella. I'm responsible in the FIWARE Foundation for the Smart Data Models Initiative, okay, which is an initiative which is going to tackle several of the many questions that I've noted in my book that you have presented around here, and I will try to answer while I'm doing the presentation. So let me go. First of all, I want to point out that what we are doing is just presenting water management or water data management needs to tackle three potential scenarios. First scenario is we are creating just brand new smart applications for any simple solution. The second scenario is that we have a digital twin of our network, of our infrastructure that is managing the water. You can see there is a panel. And the third scenario in which we are integrating our water system with some other systems. I remember from some of your previous speeches that you have to integrate with agriculture, okay, from energy with economic management, because the price of the energy for the pumps of the water itself. So we have to integrate every water data with some other domain. So we need a cross-domain approach. Okay, and what are we doing, or what we are providing for this? We are providing an approach in which allows to create a digital twin representation of our infrastructure, of our use case, about whatever we are doing with water. So first of all, we need just as the key element, the context broker, which is going to integrate heterogeneous. I like the last slide from Antonio, that you mentioned the heterogeneity of the data sources that we are facing. Yeah, that's true, and that's one of the strong features of context broker. Second is the scalability. So we need just something for being capable of dealing with our current needs and our future needs. And the last point is about dynamism. I will get into dynamism a bit later. Okay, so what we have with this infrastructure supporting by FIWARE is to tackle the needs of the real use cases as it has been presented previously. So here what we can see is just that in order to use our infrastructure, or in order to approach of the data of our water infrastructure, we need to model it. And we need data models that get into the very details of every element of our infrastructure. Of course, NGSLD is a very successful standard for interchange of information. Okay, that's good. But even with this standard, we could model in a different way the same elements of different infrastructure. What is the result of this? That even sharing the standard for transmission of information, we are not interoperable. The Smart Data Models Initiative is tackling this problem by providing to the maximum detail the definition of the different elements that you have into your infrastructure, and therefore allowing you that the digital twin representation of your application, infrastructure, integration of systems will be feasible and actually interoperable, and not just a good try. So additionally, something that we have to grant in order to guarantee that interoperability is not the vendor locking. So of course, there can be some providers in the market that give you solutions regarding this kind of interoperability. But if you depend on something which is on a vendor side, then you have a problem because you depend on the evolution of this vendor. On that side, the NGSILD and data models provide something which is on one hand standardized by an independent entity like ETSI. On the other side is adopted by the Safe Digital Initiative of the European Commission as a building block for building interoperable business services. Additionally, this profiting from the GSMA reference architecture. So we share many of the elements already defined for the big data infrastructure and IoT. And last but not least, we are also collaborating with TM Forum regarding all the management of information. Therefore, what we provide is an environment in which we have a real open approach and long-lasting initiative that allows you actual interoperability beyond other initiatives. So, and now I want to focus in 5 simple questions for defining what is the Smart Data Models Initiative. Let me go, yeah. First of all, is that why we are a community site with the tail data models. First of all, the resources are always limited. If we are not a community site, we are running out of the resources, and if we run out of resources, we cannot provide any kind of service to the users. Okay. Detailed data models, because what we are seeing in the market, not only in the water domain, but in many others, is that the regulations do not specify to the level of the property, field, or just data. So therefore, if you don't have something equivalent to the Smart Data Models Initiative, you can lack that interoperability even having a standard. Is this just a FIWARE initiative? No, no. Actually, no. Currently, TM4 is already a part of the management of the initiative, and some other organizations are ready to join very soon. Organizations coming from outside Europe. Okay, and not only this, but for many of the domains and subjects, I'll explain later. There are some other organizations which are collaborating, and of course, the contribution of data models is actually open to many organizations into the different domains. Of course, water is one of the domains, but the initiative is currently providing support to many other domains, which is a very good thing for the water domain, because as I've explained previously, water domain is good, but it's not living alone. Therefore, if you have something with water and you are in the agricultural sector, then you need not only the water data models, but some others related with agriculture. Or the same way, if you are in a smart city environment, of course, you need to understand where the population, what are the buildings, and these kind of things in order to understand how the water management has to be done. Okay. What advantages do we have using these data models? First advantage, we care for the coherence and consistency of the data models across all the different domains. So if you have a property in one domain, in one data model, this property is the same type and means the same across all the different domains. Okay, so therefore, if there is a temperature, this temperature will be a number always independently if you are using in the water domain, in the agricultural domain, or in the water domain. And also, we provide an agile standardization. Our life cycle of management of the data models is quite agile. So we can move from one definition to other in terms of weeks or a month, which is something that in the current standardization bodies is maybe out of their ability. And with that, what we provide is not for the sake of being quick, it's for the sake of being at market speed. Because if you are not in the market speed, any regulation becomes obsolete sooner or later. And what we want to do is just to be ready for any actual and future need that our users have in their businesses or in the management. What happens if these data models that we have do not cover your needs? It happens. And in fact, I guess it was Antonio who was describing that they have taken some of these data models and have extended with additional properties or whatever that cover their actual needs. So what we provide, first of all, is just something which is open and you can adapt to yourself, of course. Secondly, we strive to make it the data models general and flexible. So the fewer mandatory properties, the better. We have to justify quite strongly if you want to make some property of a data model mandatory. And last, maybe, and it's quite likely, especially right now that we are in some early moments of the data models, you can contribute if you don't find out something which is actually useful for you. So it's not something which is a static, written in stone, so you can change it definitely. And where the easiest point is, where can you find this? We are currently using GitHub as a repository, and we have a front end that we will browse in the coming slides, smartdatamodels.org. So what is the main structure? The main structure of the initiative in the repository is that we have different domains. Smart water is one of these domains, okay? And is related with others. And every domain has subjects. What are the subjects? The subjects are groups of data models that share something or they are related in some sense, okay? And all these data models, and I like the presentation of Aitor, are not invented, are not brand new. Most of the cases, these data models are coming from the translation of existing regulations. So something which is already in the market, but is not finding the level of detail that the people, the users, need to implement this into the various systems. If they don't have that detail, then what can happen is that they are not actually interoperable, and we solve this by providing this open definition and payloads of example, and even a JSON schema which allows you to validate if a payload really meets the definition of the data. So this is part of the structure. As you see, there is an umbrella repository called named data models, in which you have general documents, the directory of the domains, the inventory, and many files compiling some of the properties of all the data models, like the required properties, the amount of documentation available, the examples available, and so on. As you can see, there is a specific domain which is smart water, and inside this smart water domain we have several subjects. You see also, I want to emphasize the existence of the cross-sector domain, which is a virtual domain in which there are some data models which are extensively used across all different data models, including water, like weather. The weather is something, of course, it could be just a domain by itself, but it's used in smart water, in smart agri-food, in smart cities, in smart environment, and possibly in some others. So it's so useful for many other domains that there is a specific domain, and the subjects below this cross-sector are linked into the different domains. If you are familiar with GitHub, I have to tell you that these subjects are repositories by itself, and these subjects are linked to the domains repositories like submodules, which allow us to independently evolve any kind of subject, and this subject is automatically updated into every domain that is linked to. Okay, and inside every subject, what you have are the data models, which are directories containing three basic elements. First of all, examples of these data models, payloads. Okay. Second, a JSON schema which validates these payloads. And third, a specification written describing all the written in Markdown, describing all the elements in these data. Okay, what is currently available? So you have available data models for EPANET integration. You can see curve, junction, pattern, pipe, reservoir, tank, and valve. Okay, they are already available, and they have been implemented for a successful integration with EPANET. EPANET is a software for simulation of water distribution networks. There are some other models which are incubated. So it's been developed, but we know that we'll have maybe in coming weeks, maybe a month, no longer, I'm expecting, which is network and simulation, which are data models specifically for this kind of integration with EPANET. Additionally, there are some evolution in the device data model in order to allow to use the properties required for the water management. Okay, and we have also some other data models which are related around weather, like weather observed and weather forecast. And this is in one subject. You see in the right part of the slide, sorry, because it's quite small, the four existing domains, but the four existing subjects. And you have there the list of subjects which are possibly in the coming weeks, months, be available. So one regarding water quality, regarding water consumption, distribution, water management KPI, social media, because sometimes you need to communicate to the users of the water things. So we'll have this kind of integration, GIS integration, and wastewater collection. And possibly, depending on the activity of the contributors, there will be some others. So because this initiative, the good point is it's quite flexible, and if there is an unmet need, we could create a brand new subject and allocate it and make it consistent with the rest of data models available. So, and now I want to browse just a bit, the services that we have already available for the users. So for the users, which can be either users of the payloads or contributors to the data models. What you see here is a group of links in which you can get some resources. Like, first of all, are the news. So what is happening? What are the new data models coming in? So I'm just clicking, and what you see are it's quite a small, let me try, oh, too much big. So the official list, so there are points that not every day, but maybe every day, twice, 3 times a week, have updates regarding any of the data models of the initiative. There is 2 databases for looking if there is something similar to what you need in the data models. If we click here in the first, we can go to the database, which is available in the very front end. Let me go here. It's coming, yeah. And depending on the connection, yeah, here we are. Okay, let's look for water. If we look for water here, then you can have here below every data model which is somehow related with water. You have here enumerations, you have attributes, you have wherever is related with water in terms of the name of the schema, name of the property, or if it's an enumeration. And you have here also a database in order to look for anything that you are interested in inside the definition or the okay, if we go here to the description and we look for water, I'm going to reduce a bit because it's a bit, oh, if I write properly water, it will be much better. Well, okay, let's go slow because otherwise I've already written, yeah, it's coming, yeah. And then what we have here is just every property that in their description talks anything about water. So with this, if you want to know, oh, is there anything for me, then you can look for it, and maybe you find out the data model, or maybe you know that you have to create a brand new one, okay? We have also a subscription to news. So you don't have to browse the site, but you can subscribe to the water updates. So you go here, but I don't know if I click in the, sorry, because I clicked in the wrong place. Let me go back. Yeah. 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 If I click here in the right place, then you can subscribe, and there is a specific domain, which is the last one because it's alphabetically ordered around smart water. You click here, you put your email here, and then you receive once a week all the news regarding the data models of this initiative. And there is also how to support to the issues that you launch. There is a contribution manual on how to submit new data models, and there are services online for checking. And here in the right part, you have examples on how to implement this or how to use the data models. So there is plenty of help, and we are looking for. And I'm just going to finish just informing you what comes next. In terms of the NGSI standard, so this morning in the Greencities Congress, we have explained what is coming regarding blockchain and distribution ledger technologies and their integration with the NGSI platform. We are boosting also the development of reusable artificial intelligence. We are providing data services and marketplaces for the use of these data. And regarding specifically of the initiative, the smart data models, okay, we keep on growing on the amount of data models. We keep the cross-domain perspective, so everything that will be consistent across the different. We are now in the process of integration the 1,300 data models coming from schema.org into the initiative, so it helps you to integrate anything that is already available. Possibly you don't know, but schema.org is an initiative of Yahoo, Google, Yandex and some other search engines regarding how the information has to be structured in the web. Of course, they are prescriptive and quite powerful, and if they define how a people or how a water resource has to be defined, it's very difficult that you define alternative and have success at all. And we are just a smart data models initiative, which makes everything feasible to be used with our platform, but we are extending the utility by providing exports in the coming future to some other platforms like CSV, which is already available, but SQL or something else. And we are also keeping the scripting, because every data model are reviewed daily on a daily basis, and checking for errors and things. And last but not least, what we are currently implementing is that instead of just looking individually for any need, that you have services online that you can check and you don't have to interact directly with us, but it's kind of more self-service too. Just to summarize, what we provide is something that we expect and we ask the users to be useful and to reduce the uncertainty when you are implementing any system, any integration of systems, or any digital twin, that the way of defining your data models will be the same and could be open across the different domains, and or even in your case. And we provide something which is saving your time. Oh, you have to define something new. Why do you need to? There are many others that have already faced that problem, and they have condensed all the knowledge into the data model you have available for free and in a collaborative way. So this is everything that I have to tell you by today, and I'm open to your questions if you have, and just to congratulate yourself to wait here just for these 2 hours in this afternoon. Thank you very much.
Do you have any questions to Alberto?
Yes, I have a question. Stéphane Le Gall from Suez Smart Solutions.
Sorry, I'm not understanding you because of the sound.
I'm Stéphane Le Gall from Suez Smart Solutions. Thank you very much for your presentation.
Yes.
Is it possible to go back to the slide number 9, please?
9, yeah. This one?
Yes, this one. Yeah, just a clarification. So in this slide, oh, there are some noise. So in this slide, we can see that you mentioned EPNet integration. So the terms used like curve, junction, pattern pipe, reservoir, and so on, yeah, refers to a data model related to EPNet.
Yes, they are objects that are required for the integration with EPNet. EPNet defines these elements, and these elements are exported from the context broker. You meet these data models, and allows you to create the payload that you have to get to ingest into the EPNet software for running a simulation. But these elements are not enough. In fact, EPNet allows you to run not only the full network, but sub-networks. And that's why we have the element which is incubated network, because you can maybe will to run just the simulation for one part of your network, and the other point, the other data model, which is called simulation, are the starting conditions or the starting scenario that you want to simulate with EPNet.
Okay, so it was my understanding. Thank you. My question is, how can we do the link with the new subject, because water quality or water consumption that you mentioned during your talk address also some issue related to EPNet. So EPNet is in charge of monitoring water quality and water consumption. So is there an overlap between the data model from EPNet and the data model defined for the new subject, like water quality and water consumption?
First of all, I'm not the expert at the panel. So what I'm going to tell you, the only point that I want to grant you is that the data models that we'll have regarding water quality and water consumption in related with the panel will be consistent, meaning that the properties defined will mean the same in the water. If you have, it's just an example, a silly example, a flow in water quality, this flow will be measured the same way that the flow in a junction, the flow in a reservoir, the flow in a tank. So, but regarding what will be inside the water quality or the water consumption, I cannot tell you what, because I want to emphasize something. What we are doing is not just creating what we think. We are based on a real scenario. So we are integrating actually with FNet. And therefore, when we finish all the data models, you will have a tool which allows you to export from Context Broker and integrate to EPANET seamlessly. So,
maybe let me take an example. Imagine that you have to deal with a reservoir. So this entity is defined in the data model coming from EPANET, and probably this entity will be a similar entity called a reservoir, will be probably defined in the data model in the water quality subjects that the new subject that you mentioned. So is there a risk of confusion between the two data models when you use the term entity, the term reservoir for the same entity?
No, if this is the same entity, there won't be two data models. If it's not the same entity, first of all, won't have the same name. So if one is reservoir, the other will be quality reservoir or Q reservoir or whatever. So it won't be the same. So it's not allowed to have two data models meaning different things, because it takes you to error very easily. And the same for properties. If there is a need to modify let's say the tank, imagine, or the reservoir in some other domain, the first approach is to extend the data model with additional properties. If we are talking about different elements, but that we used to have the same word for both of them, what we'll do is just to put some kind of prefix, suffix, whatever, so for making different. If they are different, they have different names. If they are the same, what we'll try to do is just to merge all the properties required, because let me mention or insist that most of the properties, or most of the fields, if you're not familiar with the terminology, are not mandatory. So in fact, in a data model with, let's say, 30 properties, maybe 3 are mandatory and not the rest. And this is the approach. So what we want to do is just to make, yes, big data models in the sense that can cope with the needs of very different. If it is impossible for whatever reasons, then there will be 2 different entities, one called reservoir and the other called reservoir 2, or something more meaningful.